So to find the amount of time it takes, the expected amount of time it takes to get two heads in a row, we can use Markov property chains. So we want to find the stationary state, but we need to find out what states we have and the probability of getting into each of them. So we consider the three states: heads, tails, and heads. So state 1, 2, and 3. So we can find a transition matrix, probability transition matrix. So for starting the state heads, the probability for state heads again is 0. In this case, because 2/3 chance of being heads, and 1/3 chance of being tails. So the probability of being in this tail state after heads is 1/3. And now from here we might get to the head state. So that's a probability of 2/3. If we're in the tail state, we have a 2/3 chance of getting into the head state, a 1/3 chance of getting into the tail state, and no chance of getting into the head state. If we're in the head state, this is one block item. So you cannot, if you get heads again, we're not getting into the head state again. You're completely getting into the head state. You have to think of this as one block. You're not getting back into it. So once you're in that state, you have a 2/3 chance of going into the head state, 1/3 chance of getting the tail state, and no probability of getting the head state. So instead of trying to find expected value of time and all that, you could look for the stationary state. So consider the stationary state pi1, pi2, pi3 times by the probability matrix, and we have pi1, pi2, pi3. So to solve this system, so when you multiply it out, I get 2/3 pi2 plus 2/3 pi3 equals pi1. You get 1/3 pi1 plus 1/3 pi2 plus 1/3 pi3 equals pi2. And then you have 2/3 pi1 equals pi3. Then we also have pi1 plus pi2 plus pi3 equals 1. Place all this information in a matrix so we can reduce it, and multiply the first equation by 3, then plug it in. So you've got -3, 2, 2 equals 0. Once again, multiply by 3 by the second equation, so you get 1, 1 minus 3, so -2, 1 equals 0. Third equation, multiply by 3, so you've got 2 pi1, 0 pi2, minus 3 pi3 equals 0, and 1, 1, 1, 1. Alright, put the last row on top, so 1, 1, 1 slash 1. This plus 3 times this is 0. This plus 3 times this is 5. So the first row plus 3 times the last, 5, 5, 3. This subtract this gives me 0, minus 3. This subtract this gives me 0, negative 1. And this minus 2 times this, 0, minus 2, minus 5, minus 2. But the information which is useful is this, so you've got pi2 is equal to 1/3. Alright, so we could plug that into, well, this equation here, and this, and the final equation, put that all together. So you've got pi1 plus 1/3 plus 2/3 pi1 equals 1. So you've got 5/3 pi 1 equals 2/3. So pi 1 is equal to 2/5. Then we've got pi 3 from this again is 2/3 times pi 1, so 4/15. And then you've got, that's all we need actually, because pi 3 is, we want to find, that's the state for heads. So the expected recurrence time for pi 3 is 1 over this, so 15/4.